Hello and welcome to the video. Uh, this is a short video to explain about convolution and max pooling, how the calculation is being done. If you are aware of image processing, it should be simple enough to understand. But most of the people do struggle to understand those calculations, and where it is required when you actually create a model, be it Python or be it it's Keras or TensorFlows or anything. You have to know the input and output. What's the input? What are the filter sizes? How to place, and what are the numbers I should put actually. So then only you can make a model, and then you can test and deploy it. So knowing numbers are very important here, and I just took AlexNet. AlexNet is not the first architecture. I think the first one is the LeNet by Lee Kun somewhere in 90s, and of course there were no GPUs that time, and CPUs were also not so performance were very less, so it was not well experimented, in fact not experimented, and AlexNet is the first one which won the ImageNet competition, and it was running 2 GPUs. That's why if you see the architectural diagram here, they split up into 2 rows. The first one, if you see here, this is for GPU 1 and second one for second GPUs. I assume that you know CNN in high level. This video will actually help you, to understand the max pooling and convolution calculations. But I'm not going to talk about everything. I may be skipping the dense network or fully connected network. I won't talk about normalization and other ReLU items. I'll just talk about the 2 things. One is convolution, and second one is the max pooling, how the calculation happens, how the filters are applied on the image, on the matrix. So it's basically matrix calculation I'll be talking about. So the input image for AlexNet is 224 by 224. So it's a color image, so there will be RGB direction. So it is actually a 224 into 224 into 3 matrix. The first convolution layer, we apply a filter of 11 into 11, and we get an output of 55 into 55 into 96. How? That's what we will look into it. Now, in matrix, there is something called dot product. When you actually apply dot product, it basically multiplies x1 position with x1 position, x2 position with x2 position, and do a sum of all, and final output is simple scalar. It's not a vector, it's a scalar output. So if you see here, our filter is actually 11 into 11, and z direction is basically 3, the same here, right? So when you actually take this filter and apply it on the first place here, so it takes 11 pixel in this direction, 11 pixel in this direction, and the output is actually a single scalar, right? For you can assume that just pick the first blue color filter and do a dot product with the blue color here. What you get, a single number, right? Now because it's 11 into 11 into 3, and this is also 11 into 11 into 3 from the image, so you essentially you have to actually add even R, G and B, all the 3, right? Because you have to consider the Z direction also. So this 3-dimensional filter multiplies with this 3-dimensional image, and the output is nothing but a single number, right? Now this is the first number. So this filter has to move and apply the filter till end, right? Now how much it has to move? So that's what we decide. So for AlexNet, it is stride is 4. Stride is nothing but how much pixel it has to shift. Now it will shift 4 pixels and start applying the filter, and it does the calculation. So the first place it will be 1 to 11, the filter position. Second position will be 5 to 15, right? Because it moved 4 pixels. Similarly, the last one will be 217 to 227, and there are 55 moves. Similarly, in y direction there are 55 moves. So it actually gives you a two-dimensional output of 55 into 55. After multiplying two three-dimensional images, it gives us a two-dimensional output. Now we have 96 filters, right? We have total 96 filters. So this is a two-dimensional output. Now if we have 96 such filters, we actually get 55 into 55 into 96 matrix. So the final output after layer 1 is 55 into 55 into 96. Now to know this number 55, we don't need to actually go through. There is a simple formula where you take the image length in x direction minus filter length in x direction divided by stride plus 1, because those many times it will move till end, and the last position is plus 1. So this is the formula to calculate this number, to reach this number. Now there is a difference here. If you see, there is, it says 225 into 224, but the calculation we are doing 227, right? Because it applies a padding of 3 pixels in both x and y direction. That's where if you see the original paper of AlexNet, it talks about 224 into 224, but actually when it applies into the filter and it does convolution, it does with 227 into 227. The next layer is actually max pooling. So the output of 55 into 55 into 96, we will apply a filter of 3 into 3 with stride 2. In max pooling, what we do, it is just a max calculation of a two-dimensional, right? So what we do is, in 3 into 3 matrix, we just apply it and we see what is max. Whatever max comes out is the output, and it is not 3-dimensional, it is a 2-dimensional filter. So what we get output? So again, same calculation. X direction length is 55 minus 3 is the x direction filter size, filter length, divided by stride, which is 2 for max pooling layer, plus 1 is the last place, equal to 27. So what we get is 27 into 27 into 96 is the output after max pooling. Now this will be applied another filter in convolution layer. So next layer is convolution layer, where the filter is 5 into 5, stride is 1 here. So basically it will move 1 pixel at a time, and there is a padding here. So before we apply filter, we need to do a padding. So because the size was 27 by 27 and we have to apply filter 5 into 5, we have to do a padding to make the calculation so that it will fit in properly. The complete, basically the move will fit in at the last position. So this padding of 2, when it says 2, it is basically 2 in all the sides. So the x length 27 becomes 31 because 2 this side, 2 this side. Same case with y. So it becomes actually 31 into 31 into 96 before applying the filter convolution. So now the filter size is 5 into 5. Because it's a convolution layer, the z direction will be same with the image, right? With the matrix. So this matrix has 96 as z direction, so the filter will also have 96, and it will start moving from here. It is the same calculation again. 31 is the length, 31 minus 5 is the filter size, divided by 1 is the stride, plus 1, the last position equal to 27. So finally what we get is 27 into 27 into 256. Why? Because we have 256 such 3-dimensional filters. Next comes max pooling layer. Again we apply 3 into 3 with stride 2, and what changes here is again x and y. There is no change in g because it's a max pooling. And the calculation is again similar, 27 minus 3 by 2 plus 1, which is equal to 13. So the final output is 13 into 13 into 256. Now next layer is convolution layer, which is a third convolution layer, and here we apply padding of 1, because first thing is the padding. So when we say padding 1, the x and y becomes 15 into 15, right? And we apply a filter of 3 into 3 here. And because it's a convolution layer, z direction is again will be same. So our filter will be actually 3 into 3 into 256. And when we apply the output in x direction, the calculation is again 15 minus 3 divided by 1 is stride plus 1 equal to 13. So output is become 13 into 13. And we apply 384 such filters, so the output will be 13 into 13 into 384. So this is convolution layer 3. Now next two layers are again two convolution layers. So there are 5 convolution layers. So convolution layer 4, again it applies a filter of 3 into 3, stride 1, padding 1, and the output is 13 into 13 into 384, because the number of filters are 384. And the last convolution layer, the filter, sorry, there is a this image is wrong. Actually, this filter size should be 3 into 3 into 384. It should be same as this matrix, input matrix, after padding. And we apply actually 256 filters here. So the output will become 13 into 13 into 256. The calculation remains same, and the final output becomes 13 into 13 into 256. So if you see the AlexNet, so before applying a fully connected network, it will be actually 13 into 13 into 196. Sorry, it is 256. So 256, because there are 2 GPUs, they have divided into 2, so it is half, 128, 128, and you can see it becomes 13 into 13 into 256, including both. And then you apply to a fully connected network, and finally you do because there are, I think, 1000 predictions output, 1000 different output categories. So it actually calculates 1000 different probabilities, and the max is the winner. So I'm not talking about this because my aim was to actually calculate, to see the max pooling and convolution calculation. I hope you understood, and you will be able to make some new models, and you'll be able to calculate and able to understand other such networks. Thank you.